Hello and welcome everyone. Thank you for joining us today in the continuation of the project C Hello World. Okay, so in the previous video we've already explained the compilation processes, right? The pre-processing, compilation, assembly, and the linking phase, right? We said every C file needs to follow those processes before it is being compiled and before it will be executed, right? So we've solved examples from 0 to task 0 to task 5. So this task 6 here, we said we definitely need to, or not definitely, we need to install this package for us to be able to test the file. So I've already I've not solved this, right, but I've given you we've not run the program and see the output, but we've written the program already. Okay, we've written the program. It's just that we'll not be able to test the program until we have this package installed. So if you don't have this package installed, just go ahead after compiling the program, just add, commit, and push to your repository. Okay, I'm sure the checker will check it. It's just that if you don't have this package, you as the user will not, or the person writing the function will not be able to check if it is working correctly or not. But for the case of the checker to pass you, I think it will still work even if you don't have this. Okay, so I've already given you the code and I've explained the code, right? I've explained the code, so you can just go through the code and you get everything clear. Okay, so let's move on now. So this task 7 here, which says we should write a script that generates assembly code, and this assembly code that this script should generate is what is Intel syntax of a C code, and save it in an output file. So the C file name will be saved inside this variable here. So when you look at this, it begins with what? With a $sign. This means that C file here is what? Is a variable, right? It is a variable. So what we are asked to do simply here is we should write a program, a script that will generate the assembly code of the file that is stored inside this variable. So the file that we want to generate its assembly code is stored inside this variable here. This is not the file name directly. This is the file, this is the variable that stores the file. Okay, and this assembly code we want to generate is Intel syntax. So we need to specify the syntax we need to follow to generate the assembly code. So when you look at this, we are not compiling from the beginning to end. We are stopping at a particular position, which is after generating the assembly code. Since that's what the question says, we should just generate assembly code. And we said that which process of compilation produce the assembly code? We said after pre-processing we have the compilation, right? It is the compilation that generates assembly code. Do you get it? After the compilation process that it generates assembly code, and this assembly code ends with what? With a .s extension. Okay, so here it says the output should be named the same as the C file. So it means that we are not going to change the output, the name of the output file. That is the name of the file that contains the assembly code. We are not going to change the name. It's just that the extension will change. So in this case, after writing the assembly code, it will be .s instead of what? Instead of .c. .c is that of the C file, while .s is that for the word assembly code. Okay, so as you can see here, it says if the C file is main.c, the output should be main.s. So as you can see here, it is just the extension that changed. So we are not going to change the name for the what? For the assembly code now. So how do we do this now? We are to write a script, right? So before that, let me create this test file here. C. So this is task 7, right? So let me call it I think I already have a file called C, right? main.c. I think yeah. Okay, yeah, this is the file main.c. I created it already. Yeah, this is the file. It's the same thing. So I already have main.c now, right? So the next thing is the file name. Is a file that we need to work on, the file we need to write the script inside. So this is the file. Oops, I missed the vi. So vi, yeah. So this is it. This is how we create our script, right? /bin/bash. Right? So here we are compiling, but we are not going to reach the end of the compilation process. We are only stopping at assembly code, right? So I now say GCC. So now I need to specify in which stage of compilation I want to stop. I want to stop immediately after generating the assembly code, right? So I'll use this flag -s. So this is telling GCC that, okay, GCC, immediately you generate the assembly code, don't move forward, just stop here. So the next thing is to pass in the file name that you want to generate the assembly code for, and this file name is stored inside this variable, right? So I will now pass in the variable name here. Okay, so since we are told that the name should be the same, right? The name should be the same, it should not change. Okay, so there is no need for it to ask -o, give it another name here. No, since we are told that the name should be the same, it's just that the extension that will change, and this is done automatically by GCC. So here, if you look at this, it says that it is Intel syntax. So by default here, when you use compile, when you use GCC, it compiles your program, it generates the assembly code using the AT and T syntax. That's the default syntax that GCC use to generate the assembly code. It is what AT and T syntax. But in this case, we have been specific, right? We have been specified to use Intel syntax. So we need to do that here. So to do that, you need to pass a flag here, which is this MASM. Okay, you need to specify this. So what this MASM does is just that it specifies the assembly syntax to use to generate the assembly code. Okay, here you can now specify which assembly syntax you want to use. Do you get it? So here, since I want to use Intel, I will just say it's equals to what? Intel. Had it mean I want to use AT and T, I will just say ATT. But since I'm asked to use Intel, I will just say Intel here. That's all. So now what this is going to do is it will compile the file that is inside this variable, and it will generate the assembly code for the file that is inside this variable using the Intel syntax. Do you get it? So this is how the script is supposed to look like. So let's exit this. So let me compile this now. chmod, and just say +x. Yeah, so it has been compiled, right? So the next thing for us is to what? Is to export. Since we use this variable here, C file here, we are told that the file we are going to use will be stored inside this C file. So we need to store it now inside the variable. Sorry, inside this C variable, C file here, which is the variable. So now the next thing for us is to store the C file itself inside the variable. So that's why we use this export here. This export is used to create a global variable. So this export is saying what? I want to create a global variable, and this variable name is what? A C file, and inside this C file I want to store main.c. Okay, that's why we use this inside our file, inside the script. We use this. Now this file here, C file here, contains what? Contains main.c file here. Okay, because this has been declared already as what? As a global variable using the word export here. Okay, so let's do that. So now we have stored main.c inside this variable now. So it means that when the program executes, it's going to execute this file here. When we run the script, since inside the script we specify C file as the variable that holds the file, and this is the file now. Okay, so now let's try running it. Let's run the script now. Okay, so it's going to be what? 100, right? Intel, like this. Yeah, so now we have what? We have run the script. So I'm expecting that now it has what? It has generated the assembly code for main.c file. Since that is what the script should do. It should generate the assembly code for the main.c file. Right? So I will now say cat. Since the file name is main.c, we know that the assembly code will be what? Main.s. Since we've not changed the file name inside the script. So I now say main.s. So did you see that? Did you see that we got this and we got this here as well? So this is what? This is the assembly code in Intel syntax format. As you can see, it has been specified here, Intel. So this is just what the question says, and this is how you can do that. You just need to specify to GCC where you want to stop the process. We want to stop after generating the assembly code. That's why we use the flag -s for the GCC, and we are asked to specify to specifically use Intel syntax. So that's why we use the word -masm, right? And we need to pass in what the syntax we want to use, which is Intel. And I also said by default GCC use the AT and T, and we've seen how to do that as well, how to use that. You can simply instead of saying equals to Intel, you just need to say equals to ATT. So that's just the compilation process. Okay, that's just what this question is asking us to do. So you can add, commit, and push to a GitHub, and then you can run your checks. Okay, it will work. All right, so let's move on to the next task here. So this task here, we should write a C program that print exactly this text here, followed by a new line to the standard error. Okay, So we are printing to standard error. So you are not allowed to use any function listed in the name section. So we cannot use printf, we cannot use this put, we cannot use putchar, we cannot use any other standard function now to use for printing. And the program should return 1. And it says your program should compile without any warnings when using the wall GCC option. So before we solve this, let me explain something quickly. So there is this function here, or before that, there is something you need to know, which is the standard input, standard output, standard error. I've already explained it in my video on shell redirections and filters, I think. Yeah, we've talked about the standard input, standard output, standard error, which the standard input is std in, right? And we said it's basically your keyboard, right? That's where we type in our input. That's what takes the input, right? So std in is denoted with what? With 0. We have the std out, right, which stands for standard output, and it's denoted with what? With a 1. And we have the standard error, stdr, right, which is denoted with 2 here, right? So just take note of these different streams here. We have the standard input, standard output, standard error, and these are represented with this digit 0, 1, and 2, right? So this question says we should print, right? It says print exactly this to the standard error. So we are printing to the standard error, okay? We are printing to standard error. So we are going to use this here, -2, right? So before this now, do you understand this concept? I'm sure you get this, std in, std out, stderr. So before this, let me open this function here, the putchar function. I want to use the putchar function to show you the function we are going to use here. The putchar, where is it? Where is putchar? Well, is putchar not available here? I just want to show you the putchar function. No. Oops. Yeah, seems like the putchar is not here. I just want to see the function, how the putchar function is, so that I will be explained. I will be able to explain the function in which you are going to use to get this task done. But anyways, I can explain it like this. Let me just try explaining it like this. So here, if you can remember, I'm sure this is how your underscore putchar looks like, right? It's something like underscore putchar like this, and it takes in an input car, right? And then C here. So inside this function, inside the function, you have something like write, like this, right? And then what? And then 1, right? And then and C, and then 1 here again. So we are going to use this function here now, the write function. This write function is used to print to what? To a string, either the standard input, standard output, or standard error. So all you need to do is say write, that is, you need to call the function. The function takes in 3 parameters. So you need to specify the function, that is, the first argument of the function is you specifying where you want to print the character to. Is it the standard input, is it the standard output, or standard error? So since I'm interested in printing to standard error, and we said standard error is represented with the digit 2, right? So I need to pass in 2 here, right? So that's the first argument. So the second argument is what? Is the message, the text in which you want to pass. In this case, I want to pass this text here, this array, sorry, this string here. So since I want to pass this, I need to pass these strings here. I will just pass it here, right? So the next thing is what? Is the size, the number of bytes you need to print this. So to do that, you need to count, okay? How many characters do you want to print? Let's say I have HE here, just HE. This is what I want to print. So here I will just specify 2. I didn't mean I have L as well added here, so I will just say 3. As you can see, this is 3 characters, so you need to specify 3, which means you need 3 bytes. Okay, so that's exactly what we are going to do. We are going to use this function here. Okay, so what I will need, what I will do here now is simply say, let me now open the file first. Since this is a program, let me open the file. So vi paste, so hash include stdio.h, right? Now I think the write function, the function we're going to use is inside this thing, uni std library. So I will now say hash include uni std.h. So for you to use the right function, the one I just explained, you need to import this. Okay, include that. So let's write the function now. So this is how it's supposed to look like. Like I said, we need to say write, then we need to specify where we are printing to. So in our own case is the standard error, which is 2. So I now say 2. So the next thing is what is the string. This is the string I want to print. So I need to copy this here. So this is, since this is a string, I need to put it within what? A double quote. Right? Since it's a string, it needs to be within double quotes. So I'll paste this here. So let me just maximize this here. So I have this now. But if you look at this now, there is another what? There is another quote here, double quote here. Right? So it means that I'm not going to get this quote printed. Instead, it will be misinterpreted. Right? This is not, this is going to treat, it's going to treat this as the closing quote of this one. Do you get? It's going to print this, consider this double quote here as what? As the closing quotation for this. While this one here now is closing, but it has no partner. So it's not going to print this thing the way we want it to. So since the text I want to print, which is this, as you can see, it says exactly. So we are to print including the what? The double quote here. So it means I need to escape this double quote here. I need to add what? A backward slash before it. This is going to tell your compiler that, okay, whatever that comes after this backward slash, just print it the way it is. Don't give it any special treatment. Because you know that without this backward slash, we've seen what will happen. It will just consider this as a closing of this opening double quote. But since we want to print it the way it's supposed to, the way it is, we don't want it to be given any special treatment, then we can just escape it. So that's the essence of this backward slash. So this is going to print everything here, including the word, this double quote here. It's not going to print with the backward slash. This is the escape character, right? So here, the third argument is the size. How many characters are here? You can count how many characters are here. Okay, but I've counted it already. It's 59 characters, including the spacing. Okay, so I'll just pass in 59 here. Okay, so here the question says we are expected to return 1. So the program should return 1. So I'll just say return here, and then I'll pass in 1. Right? So now the next is Betty documentation. So I'll just say main. I'll just say main function, right? This is the main function, and then the return, I'll just say 1. Alright, so now let's try running Betty on this file first. So 101, oops, that's not the file name. Good. Yeah, so as you can see, Betty is fine. So the next thing is for us to compile. It says your program should be compiled with this without any error. Sorry, where is it? Yeah, it says your program should be compiled with this without any error. So to be on the safer side, let me just copy this entirely and let me compile using the command. Okay, so let's see. Yeah, so it has been compiled, right? So let's run this compiled file now, which is what? This is the compiled file dash quote, right? So let's run it. So this quote. So did you see that we got, and that piece of art is useful, and this date here follows. But as you can see here, I missed a new line. So let me modify my code a bit. Here there has to be what? A new line here after the text. So I'll pass in backward slash n here. So I believe this should be fine. So let's compile and let's run it. Yeah, so as you can see, we got the exact text printed. Okay, so now how do we check the return value here? We can simply use something like echo, then dollar, then question mark. What this is going to do is it is going to display the return value of the previously executed program. So the last program you executed, right, it's going to display the return value. So don't forget, this program, this is our last program. This is the last program you executed, dash quote, right? And this program prints this, right? It's printed this. So when I print this now, this echo dollar question mark is going to print the return value for this program now. And don't forget, what was the return value? We set it as 1. So I'm expected to see 1 printed. So let's press enter. So did you see that? Now I have 1 printed. Okay, now I have 1. So it means my program is working and the return value is also what I was asked to return. Okay, without any errors. Do you get it? So this is just what the question is asking you to do. Okay, so this is the end of today's session. So we'll meet in our next session. Thank you very much and goodbye.